Hey there, and welcome to the back shop. Today we have a 204R core. We got to tear it down and see what we're working with. This thing came out of a 1985 Buick LeSabre, and it's going into a full custom 1930 Model A Ford hot rod. It's going to have a small block Chevy making about 450 to 475 horsepower. So we're going to build it back up to be commensurate with that application and install a whole boatload of billet parts and other upgrades so that the 204R here can thrive and survive under engines making the kind of power that this one is. So customer's going to use it mostly as a cruiser. He's going to get on it, he's going to have fun with it, so we want to make sure we build it up the way that it'll kind of be fit for purpose. So anyway, you're not familiar with the 204Rs in terms of how to identify them and you don't already know, basically you want to look here at the ID code on this tag. If you see two letters just like this is O and G, that'll correspond to a unit made between 1981 and 1985. If you see three letters, it's going to be an 86 and up unit. Alright, so these were installed in a multitude of different vehicles, passenger cars, performance to grocery getters, even some diesels. This is 10 millimeter, as well as other applications. I don't know all of them to the tune of 100%, but suffice to say, quite a diverse, vehicle product line that saw the 204Rs. All right, if you want to take out the pressure port taps, those are 7/16, so I'm not going to do that. We're not even going to use this case. We're actually going to be using another case that I have already prepped and has been modified to fit into the customer's vehicle. So this is going to be your line pressure trap port, 7/16. Making sure you do line pressure tests on any TV-based transmission is absolutely critical, so you don't want to skimp on that. All right, the torque converter code, I'll flash it up on the screen, but it's going to be CG8C. So we are literally only using about roughly half the parts and components inside this transmission. Alright, always like to test for input end play. So there's three different spots in this transmission where you're going to actually measure front end play, and they are the rear gear train, the mid case drum travel between the gear train and center support, and then of course the input shaft for front end play. Now you got to phase in the latter two, or I should say the rear two positions. The rear gear end play is like 4 to 10 thou. The drum travels between 15 and 25 thou. And the front end play is something like 7 to 22 thou. You can never ever have more rear gear end play than you do drum travel. If you do, you have a bind in the case. Alright, let's get this thing flipped over once we get this speedometer out. Okay, these all take like these bullet style speedo housings, so they're readily available in the aftermarket. If yours is somehow damaged or broken or whatever, no big deal to replace it. You always want to check the bore, and that's true of anything, any kind of bores that have parts. You want to check them. Now, this is a one-piece case design. There is no bolt-on extension housing or anything like that. You just simply take off the few parts and components that are on the outside of the case, like the servo, and then you start working your way in. Alright, as far as, and these are 13 millimeter by the way. Alright, as far as whether or not I'd recommend first timers work with these transmissions, they would not be the first. I would not train somebody on one of these to begin with. I'd start you on like a TH350 or a C6 and then work my way through the 4-speeds, maybe 727s as well. And, if you wanted to get into Dodge units, but these require quite a lot of specialized tooling, and the procedures that you're going to need to follow are kind of far and away and above more complex and intricate than your typical TH350 or 400. Alright, variety of different servos and cover combinations were installed from the factory. The only servos worth even using, even considering in terms of factory options for anything performance, are going to be your Grand National, GNX, Turbo Trans Am, the so-called high performance servos, and they're the largest ratio servos that are out there. this thing is so caked with mud, I'm actually trying to find the snap ring ends so I can get the snap ring out of it. Alright, you can loosen up the, the cover if it's like, all caked and gunked over like this, but I just kind of dig around it, see where the ends are, and I may be able to get to it from here. A lot of dirt. Alright, so here's one end of it. What I'm going to do is just tap. Well, I went too far, but ideally I want to tap until I get some of this servo exposed here, or the snap ring end exposed here, so I can kind of pry it out. Like I said, I went too far, so I've got to back up. Alright, and then see if I can get in behind it. And sometimes this is what you have to do. You gotta gradually work its way, work your way around it, so to speak, so you can get it out. Okay, so just like any other servo assembly and band, you want to make sure that you have band clearance dialed in. I mean, you can use servo inboard travel as a measurement kind of to infer what your band clearance is, but as far as truly determining whether or not you set up the servo correctly, servo inboard travel is largely meaningless. Okay, it just doesn't matter. What matters is the actual band clearance itself. So this is your garden variety grocery getter style servo. You would never reuse this in any kind of performance application. I wouldn't recommend you reuse it at all. For any 204R that you're going to build, I mean, unless it's purely for a stock rebuild and a stock vehicle that is doing nothing but, well, like I said, getting groceries, you want to install a billet servo there. As my recommendation, most of these transmissions being built these days are for more performance-oriented applications. Okay, here's your TV linkage arm. Then you got your dipstick seal, and then this is going to be your TV seal. And we'll go ahead and put this thing over. Let the fluid drain out of it. And once the fluid's drained, we'll come back and we'll start taking the pan off, taking the valve body off, and kind of going through the case. Alright, 13mm on pan bolts, they all get between 98 and 100 inch-pounds. So, one of the biggest risks that you'll face with working on 204Rs is the availability of certain parts. Most particularly the direct drums. Direct drums suffer from sealing ring groove wear in inner diameter, and oftentimes that will result in the drum being no good. Okay, there are two different drums available, I believe, for these units. The 5-clutch direct drum and the 6-clutch. Okay, 5-clutch is commonly found in some of the lower horsepower, lower displacement applications, whereas the 6-clutch is what was found on, the rest of them. So, for clearance in the clutch pack, when you go back with it, you want to be between 50 and 60 thousandths of an inch for the directs. Forwards you can run a little tighter, 30 thousandths. I think 28 to 60 is the spec. Forward's always on in any forward position or forward pattern range setting on your shifter. But the main concern is the direct clutch. All right, so it looks like we have quite a nasty looking pan here. And somebody used one of these flimsy ass rubber gaskets This is obviously not original to the unit. Maybe someone's been in here before, I don't know. No history on it other than, you know, where it came from. Alright, let's see what kind of mess we're gonna get ourselves into here. Alright, filter is equally nasty. There's something burn up pretty bad. If it's direct clutch, my guess is that we're gonna see sealing ring groove wear on the inner diameter, which is the last thing we want to see. Okay, valve body. These 4 bolts are tall. They will go back in those locations. The rest of them are largely all the same. So you have your torque converter, clutch solenoid, your wiring harness. These are just like the 700R4s in terms of how the torque converter clutch is controlled. It's electromechanical in nature. I got my 13 millimeter. I believe that's, yep. So this is going to be your governor housing. So I'm going to pull that out first. 4 bolts. Alright, to my knowledge, I could be wrong about this, but to my knowledge, there are no commercial off-the-shelf governor modification kits for these transmissions. So you had 3 different types of governors. You had a diesel governor, you had what I will call the standard grocery getter governor for the gas applications, and then you had the high performance governors that went into things like the Grand Nationals, Turbo Trans Ams, the Monty Super Sports 442s that had lighter secondary weights. Okay, your primary weights control your part throttle shift points, your secondary weights will control your full throttle shift points, and if you need to modify these to raise your shift points, what you're going to need to do is, you know, start taking meat off of it, start taking material. And my customer knows that. We actually had a good long discussion about how we want to set up the calibration for this unit and some of the considerations that we will need to take into account. And one of those is fine tuning. So once this goes back in and we have, you know, good TV pressure on the pressure test, it passes, we will have to then, you know, have him do a test drive and evaluate how things are. Okay, here's your 1-2 accumulator housing. We'll take the bolts loose, 10 millimeter. Alright, I have a separate video on a technique you can use to kind of fine tune the 1-2 shift, make it a little bit firmer in a either factory to mild performance application. I would not recommend that you block the 1-2 accumulator off on such a, you know, such an application with a tight converter stall. You know, as far as a loose stall, something like 28 to 3200, I would block this off, block the 4th accumulator, and the real high stalls you can leave the 1-2 check ball out of the valve body, or off the valve body I should say. It's going to be the middle of the 3 check balls that lie between the valve body and the spacer plate. So you would just punch this pin out right here for your piston and then pull the piston out. Always replace the pistons. I forgot to turn my air on, so you know we're not going to do that. Alright, 10 millimeter on your detent roller, and then pretty much everywhere else. So here's going to be your throttle valve linkage arm setup. You want to make special note or pay close attention to exactly how this goes together. Alright, because this can frustrate you if you don't. Alright, for those of you who watch my channel for a while, this bench is probably familiar, or looks familiar, at least it should. This used to be in the front shop, but I've moved it back here. I've, you know, changed benches out and whatnot. I like that bench a lot better. This one I have to actually modify. I have to increase the, you know, surface area of the trough so that it doesn't like to spill out onto the ground. Alright, so notice these bolts here. I know I got one more that I got to take loose. So the 3 bolts here are going to be a little bit longer, so you just want to make note of their location here and here. All right, we got a bolt here, got some more bolts here. All right, and then also pay attention to the routing that you see for the, for your harness. We'll get this totally out of the way. So 10 millimeters well on the TCC lockup solenoid. We're not going to reuse the harness or the solenoid. All that stuff gets replaced. This one wants to fight me a little. Wants to fight. All right, and then your case connector here, you're going to have a retention tab that will basically secure the harness itself to the connector. So just lift up and pull, and it'll come off. All right, this is going to be your feed pipe. I mean, you could try to see if it'll come off here. Just carefully, and I mean carefully, pry up on it. You don't want to break it. All right, there's valve body mods that you could do. I have a whole separate video that gets into the valve body and all kind of different tips and tricks. So if you're curious, check it out. But you can kind of convert this to a quasi-manual if you want, or gear command. I'm looking. Am I missing a bolt? No. It's just pretty stuck on there. All right, there's our check balls. There they go. All right. So we got check ball location here, a check ball location here, and check ball location there. Do not like when the gasket sticks to the casting. So let's take a better look. So here, this is going to be your intermediate clutch check ball. It's a flow control check ball. That's what I was alluding to earlier when I was talking about leaving that out in high stall, high RPM applications. All right, we are going to reuse this valve body, or at least we're going to try. Hopefully it's not all messed up in some fashion. All right, one more bolt here for our hold down plate, 10 millimeter. And this is like heat bonded to the main spacer plate. So we got gaskets and the plate all kind of glued together. No good. Alright, these are your center support feed bolts. If you are going to dual feed the direct clutch, you need to block off the high reverse feed passage in the center support. $10 millimeters. Alright, now you have a selector shaft retention nail. Just want to be real careful when you deal with this nail. You don't want to bend it. And that one I have a feeling is going to fight me a little bit. That's not what I wanted. So that's, I'm going to have to drill that out. Luckily we're not reusing this case. So luckily. That can happen, unfortunately. It is what it is. So I'm not even going to bother taking the selector shaft nut loose. Well, I guess I should because I need to get it off anyway. $15 millimeter. All right, we are going to reuse this. 13 on your parking pole guide plate. Alright, we're going to have to kind of maneuver this around the selector shaft because I broke the stupid pin. So there it goes. That's how it's oriented. Alright, let's grab up the check balls. I'll zoom in so you can see their orientation. So 7 total check balls. 8, excuse me, 8. Forgot about that one. Okay, 4th accumulator. Anything performance oriented, you want to block this off. You do not want to run the 4th accumulator. That's true. 204Rs, 704s, 4L60Es. Alright, go ahead, check the board, make sure it's in good shape. It's not scored up. If you are going to reuse it and install a new piston in there, you want to make sure that there's no scoring or any problems that would otherwise potentially cut that rubber seal. All right, get that magnet out of there. Get this little nut. All right, torque converter issues. So if you have a little O-ring here that's kind of either hardened or otherwise cut, you'll have problems with the torque converter. Falling out of lockup or just not going into lockup at all. And these transmissions are extraordinarily sensitive to that. When it comes to having the converter clutch slip. If it's allowed to slip, you're going to have massive overheating and burn up the entire front of the transmission. All right. I know you can't really feel per se, but through a video screen or whatever you're watching this on, but this is actually somewhat hardened. All right, let's see if we can get this pump out. I'm gonna come in behind here. See if I can work it loose. Okay, 204Rs, never reuse the stators. Always replace with a heavy duty or hardened stator. It's going to be a selective washer. This is going to control your front end play. All different colors for these washers are available and they correspond to different thicknesses. Obviously that doesn't go on there. Alright, now what we have here is our spacer or return spring for our overdrive clutch. And then the overdrive clutch itself. If this is still factory and someone didn't modify the clutch, there's going to be a friction, 2 steels, another friction, another steel, and that's it. Alright, as far as I know, there's no known selectives for the overdrive clutch. So, whatever clearance you have, that's kind of what you want to manage to going back with it. And what I would recommend you do is take a friction and your overdrive apply piston to the machinist, or you can do this yourself, I guess. You have the tooling. And machine down this overdrive piston here, roughly 80 thousandths of an inch is what I typically take off. And that will allow you to fit an extra friction in between the 2 steels that are arranged consecutively, just like this. Alright, so here is our pressure plate or backing plate. We have a friction, it's worn out. 1 steel, 2 steels, both flat, another friction, and then your 3rd flat steel. Alright, what I was saying prior to the battery dying is that If your engines are going to be making more than about 400 horsepower or so, maybe like 450 on up, you will want to replace this factory ring gear with a billet steel version of itself. These will crack under high RPM, high torque, situations. So otherwise, if you're going to rerun it, check your journal, check your splines, check your teeth, check the structure in here. This is where they like to crack. Check for any unusual or excessive wear on your thrust surface for your thrust washer. All right, this is the thrust washer. And it's going to go just like this. All right, with the 2 tabs thusly. And your bearing is going to have the inner portion facing out or facing you. Alright, so now what we're going to do is install our first special tool. We need to compress the spring so we can take out the snap ring for the overdrive apply piston, and then we can get the center support out of the case and evacuate the rest of it from there. So the tool we're going to be using is Kent Moore. It's a 2-part deal. You're going to have a bridge and a compressor element. So the compressor element is going to be J29334-1, and then the bridge is going to be the same prefix but -2. So position your compressor just so that you have access to the snap ring groove, kind of like this, and then you want to make sure that your 2 hours are pointed toward the valve body, and then just go ahead and install your bolts. It's going to be a little bit awkward just simply because this tool is not really meant for horizontal use like this. It's really intended to be installed with the transmission vertical on either a bench or engine stand mounted fixture. But we're going to see if we can make do here. Alright, I'm going to get this positioned and basically centered, and then now what I'm going to do is I'm just going to use a ratchet to compress it so I can get the snap ring out of the snap ring groove. That's basically it. And I know my gloves are making all kind of farting noises. I always say that, but trust me, it is not me, it is the glove. Alright, once you got it sufficiently compressed, go ahead, come with snap ring pliers. I'm going to try a few different types. These should be sufficient. If not, we'll break out some other ones. Yep, these are good. Alright, so that takes them loose. And I'm just going to relieve pressure gradually. And then we'll go ahead and take our retaining bolts out. I can get the extension on. Alright, I'm going to put those bolts in with the rest of them and go through the cleaning cycle. And same with these things. Alright, looks like this is kind of caught up still. So that's the situation you find yourself in. Let's go like that. And you should be able to take out your overdrive apply piston and your return spring assembly. Okay, inspect the return spring assembly, make sure it's not boogered up, make sure none of the springs are broken or whatever. Here, you want to make sure that the apply piston itself is not worn, it's not grooved. You know, you cannot feel defects in the surface. So all on the top here, you would put this on a lathe and machine about 80 thousandths off of it. And that will allow you to stick an additional friction in there between those two steels that you saw a little while ago. Alright, now we're going to go ahead and attack the big snap ring. What you sometimes will see is folks come in like this and try to, you know, get the snap ring loose. You know, get it started, so to speak. And you can do that as well. If you, you know, if this doesn't work, or you kind of, you know, hit a wall with it as you're trying to get it out, then you can go ahead and use big snap ring pliers. You just want to be careful whatever it is you're doing. I'm kind of standing away from it so that if it does fly out, it's not going to, you know, hit me in the face or the chest, or, you know, soak me in transmission fluid. Now, sometimes the center supports, they will get ornery. They will not want to come out. What you could do is see if you can get the band anchor pin out for the intermediate band. Most of the time they're not going to come out willingly either. Alright, get like as firm of a grip as you possibly can on it. In fact, you know what? I'm going to grab pliers. The idea is you want to withdraw this thing as straight out as you possibly can, because it is a very, very snug fit into the bore. Alright, so here's the center support itself. You have your 3 sealing rings here. If you were going to dual feed this transmission, you would leave this sealing ring out, and then you would block the high reverse feed passage. This thing wiped off, which I believe is this port here, or this may be direct. I'll annotate the video. It's been actually a little while since I did a 204R, but that's what you're going to do. I have a video that covers this in detail. This washer is not selective. You just want to check your journals here, and then you want to check the inner diameter, especially here where the sealing rings go, for your intermediate shaft. Just feel in there, make sure that there's no ring groove or ring cut. If you have that, then obviously this will need to be replaced. These are relatively common, no concerns if that's what you have to do. You have a lip seal here, and the lip faces down into the bottom of the cavity there. Alright, so now I'm going to see if I can get that band anchor pin out of here. And it looks like it's still stubborn, so just dislodge the band. I think that thing is stuck. Like the pin itself is stuck in the case. And so, you know, if you have that situation, you're gonna, you know, you may end up having to fight a little bit with the, you know, with the band to get everything free. That's no good. All right. Probably a little more dramatic than what was necessary. So this thing is smoked. Look at that band. We'll take a look at that in a little bit more detail in a second, but I mean, Jesus. Forward clutch just totally charbroiled. Charbroiled. So the backing plates for these forward drums are selective. I'll flash a chart on the screen. That chart will have all the different thicknesses of backing plate available. But this clutch pack's welded, so this vehicle would have been moving forward in neutral and binding up in reverse. So it wanted to move wanted to move forward in park, move forward in reverse, and binding, or moving forward in neutral and binding up in reverse. And let's see if the direct drum is welded. It may actually be welded, the direct clutch welded to the forward drum here. Yeah, look at that. Welded. Alright. Okay. I don't really care about trying to salvage that drum. We know it's no good. So we're going to take out a big hammer. And we're going to wail on it until I can separate it if I can. Alright, it's free. Smoked! Alright, so this is going to be your apply ring. Now, there are two different variations of drum and piston combos produced for the forward clutch. There is a drum that had a bleeder ball capsule, and then there was a drum that did not. These early drums had the bleeder ball capsules. They used the stamped steel apply pistons with the apply rings, and the pistons themselves did not have any bleeder capsule. The later drums, they eliminated the bleeder capsule in the drum itself. They went to one in the piston, and whatever you do not want to mix and match these, because you need to have one bleeder orifice either in the piston or the drum, but not both. And obviously you need at least one, but you need at most one. Alright, that drum is a basket case. Let's see if we can look at the direct clutch, because it also looks fried beyond all recognition. It does not want to come out. Not at all. Oh wait, here we go. We're making some progress. Alright. So this drum's no good. Right to the scrapyard with it, but we know why it failed. And we also know why the forward clutch failed. Or at least we have a very good idea. Look how much ring cut is visible here. This is, I don't want to say this is typical, but this is the typical mode of failure for these transmissions. Most of them, or at least a preponderance of them, will come in because of ring cut or sealing ring groove worn into the inner diameter of the direct drum, smoking the direct clutch, and consequently heat soaking and burning up the forward clutch. I mean, it's basically a 1-2 cataclysmic domino effect that destroys the transmission. Okay, in the case, this is going to be a number 8 selective washer. This sets drum travel between the rear gear set and the center support. I have a whole bunch of those. So I'm not even going to reuse these snap rings. I would not trust these to survive any longer. Metal's no doubt weakened. I mean, look at this. A complete and total disaster. So let's look at the band real quick, because the band will also suffered. Okay, this band is absolutely trashed. You want to pay attention to the band anchor pin location on the band itself. Sometimes these, especially if the transmission is over calibrated for a harsh 1-2, these will fail this location and you'll lose second gear and have all kind of problems. Alright, I'm actually going to move this drum off of this bench. Same with this drum. If you were going to reuse the forward drum, you would check your splines here, check your journals, check your, down here at the base for cracks. Again, for high horsepower dual feeding the direct clutch, you want to use a heavy duty forward drum with a billet steel intermediate shaft installed. CK sells them. There's, I think, one or two other vendors that make these available. But the bottom line is, if you're dual feeding the direct clutch, that will stress the intermediate shaft based on the way the clutch applies, and as a result, it will cause the intermediate shaft to kind of break off. Alright, I have spare drums, so that's what we're going to have to resort to, a spare drum. Alright, let me kind of change camera angle a little bit, and then we'll get the rest of the guts out of the case, and then we'll look at the pump. What a mess. Alright, snap ring here for your selective spacer. That spacer is what sets rear gear train end play. Okay, the snap ring itself's not selective, but the little spacer is. I have another video that I never actually published to the channel, 204R. Somebody actually installed the spacer in front of the snap ring that you just saw me take off, and I mean, that was also a total disaster. But these are available in a variety of different thicknesses, and you know how you actually set up your end play is you measure this whole gear train on the bench using a vise. We have a roller bearing here, and then our sun gear. And then once you have it on the bench, you will then measure your end play by pulling up on the ring gear with a dial indicator and see where you're at. So the sun gear's groove faces the planet, so faces you, in other words, when you're putting this thing together. And then you have your bearing. Okay. And then all this goes in like so. All right, next, you have your sun shell. So here's your sun shell and your sun gear. You have bushings. Interesting. A heavy-duty heat-treated shell is recommended. We'll look at that in a little bit closer detail in a second. All right, here's going to be your washer. This goes here on the back side. Now you have your low reverse clutch housing for your piston. The apply piston's underneath of there, so we have a snap ring we're going to take loose. Get that crap out of the way. Sorry if this is a little ponderous. This case is kind of throwing me, you know, a couple curveballs thus far, is what it is. So what I'm doing is kind of engaging the snap ring back here, right above the support, and kind of pressing in with my my little pry bar, just to try to work the snap ring free enough to where I can get at the rest of it with a larger screwdriver. I mean, how you do this is entirely up to you, but I really need to get another screwdriver back here that has like a, you know, like a little notch cut into it or something. All right, same deal, kind of be on the side. You don't want this thing flying out at you. And it's just not wanting to come out. There it goes. So this is a beveled snap ring. The flat side faces the rear of the case, and the beveled side faces you. All right. Force the outlet shaft the rear of the case and then just simply take it out. We'll look at it in a second. And I'm not really sure what the holdup is here on the support itself. There's another snap ring behind it that holds your clutch pack into place. Let me reset it. There we go. All right, check these splines. You have a snap ring here. That's going to retain your little coil return spring. You know, it's basically one big coil. So just like that, it comes off. And then you would put air here to take the piston out if it didn't want to come out on its own. We didn't have that problem here. Alright, these pistons have an apply ring. Alright, this is the orientation of the apply ring. Okay, the shorter side radius faces inboard or goes, you know, into the piston. Just like that. One time I was putting a 204R back together and I was checking low reverse, you know, putting air in the feed, and it was real weak. I could move the individual clutches and wheels while I was charging the circuit with air. I literally couldn't figure it out. I'm like, what the hell is wrong here? You know, why is this like this? It should be nice and tight. Well, what I had done, you probably already figured it out by now, what I had done was I had failed to put that little apply ring back in. Alright, where the hell is the opening? The opening is clocked here at roughly the 8 o'clock position. Get underneath of it. Alright, now the rest of the gear train, and including the low reverse clutch, will come free of the case. And if I can grab it all in one shot. Nope. Alright, so you got your rear planet, low reverse clutch pack. And this is, I know it's out of order. Okay, so your cushion plate or wave plate will face front, and then you have steel friction, and so forth. Alright, this clutch pack is worn out, but otherwise looks reasonable. Alright, this is going to be your one-way assembly for the low roller. Okay. Gonna freewheel counterclockwise and lock clockwise. So just check the race, make sure it's not like scored up. Okay, you're gonna replace your one-way assembly, never reuse those. This thrust washer, it can be swapped out for a bearing. 86 and up, that's what was in here. Alright, rear planet. These planets can be problematic. Oftentimes I'll see at least one pinion loose. Check your cam lobes. Make sure that they're not heavily worn, as well as the surface down here and the structure itself. I'm just going to put this back in here for now. Kind of keep things reasonably tidy. Okay, and then your channel that's going all around the middle, the circumference, that's going to face you. Hey, these bushings have to be replaced, obviously. They can walk. Alright, we did not look at the front planet in any level of detail, so let's do that. Same deal with the sun gear. Just check everything over. Side play. Structure. The conditions of both bearings. You know, all part of the inspection procedure that you would otherwise perform. Okay, so here's your ring gear, your parking gear, rear ring gear. Check over the teeth, check the lugs themselves, make sure that everything is okay. Alright, that about does it for the case. So again, I totally foobarred the retainer pin on the selector. Alright, let's take a look at the pump and the overdrive section. We'll do the pump first, and then we'll get into the overdrive clutch, or excuse me, overrun clutch, overdrive assembly, etc. Let me clean the bench off a little bit first so we can free up some space, and then we'll proceed. Alright, let's see what we're working with respect to the pump, what kind of condition it's in, and what, if anything, we're going to have to do. All pumps will receive a resurfacing, and that's assuming they're not warped. When these transmissions see a lot of heat, which this one most certainly did, the thing you have to be concerned about is actually warping of the castings. Seen that before. In fact, that 204R rebuild on this channel, whole rebuild series, the original pump out of that unit was warped. And so I had to go and source another pump. Alright, so you have shattered rotor, shattered rings. Actually, it's just maybe the pump rings, not the rotor itself. I mean, it's going to get a whole new rotor and slide kit regardless, but yeah. Yeah, somebody beat this thing like a red-headed stepchild, like a rented mule. And look at that. Look at that bushing. A complete and total disaster. Alright, Transgo Unbreakable Pump Ring Kit is what you want in here for anything even remotely performance. I run that kit in all of my 200s, 700R4s, and 4L60Es, where there's going to be a lot of RPM, much more powerful than stock engine, and an application like a street strip or race or whatever, even heavy duty towing and hauling. Okay. One thing to note about 7-vane pumps, they're actually very strong. This was a 10-vane or even a 13-vane. All other things equal, the rotor and the slide may have actually broken up. The rotor specifically, then the slide. But the 7-vanes are fairly robust, from the factory. And you will not have issues making good pressure with a 7-vane pump. So it is usually not necessary at all to upgrade to a 10-vane unit. Okay, so usual amount of scoring, I mean, it's to be expected given what we have just seen. And then you want to make sure you don't lose track of your little pivot pin spring. So the spring goes in and pivot pin. Alright, I didn't take the seal out, but you're going to have a drain back right here. This should be drilled out to 5/16 of an inch. And you're also going to drill it out here. That will ease fluid flow and drain back to the sump. So rotor, slide, vanes, all that stuff goes into the trash. Destroyed pump rings. You don't ever reuse this stuff. Okay, we're gonna get a new rotor guide. This is no good. For your stator, for now, leave it in. You're gonna press it out. I mean, obviously you see all the wear. This was just, you know, due to the pieces of the pump ring, you know, basically machining, if you will, the two working surfaces, you know, as this thing was working, as this thing was running. But half-inch boost valve, 300 reverse boost valve. You want to check the vacuum on the pressure regulator valve. You see that orifice right there? That has to be exposed so that you can get a pencil eraser on there and plug that hole. All right, 81 to 82 pumps had a different PR valve and a different casting here. It was, you know, a completely different stator support design. So check out my 204R pump video for a deep dive on all the different variations and engineering changes that took place over the years for these pumps, so that you know, if you want that detail or you need some information about interchange, you know, you can find it there. Yeah, I don't even know if I'm going to be able to salvage this. I'll clean it all up, take it to my machinist, see what he says. The main thing I'm concerned about is the castings being warped. So what he will do is he will chuck the stator support assembly up into the lathe, and he will spin it, and then he will attempt to back cut this side. That's his standard procedures, to trim this side and resurface this side. If his cutting tool is not making complete contact all the way around, then he knows it's warped. I mean, you can see it by eye. All right, and then for this will get chucked up in the lathe as well and spun. If it's in good shape in terms of it's, you know, not warped, then it'll go into the vertical mill, and then the deck surface will be remachined and the pocket cut, so that we have our 1 to 2 thou deck to slide clearance and 1 to 1.5 thou rotor to deck clearance. So let me repeat that because it was kind of garbled. Okay, here's your deck surface. This is the top of your rotor. So you have your rotor here. Okay, this is the top. All right, and you're going to measure it without this slide support. Okay, so slide, rotor, deck to slide is 1 to 2 thou. Deck to top of the rotor is 1 to 1.5 thou. And you're going to measure it just like this. All right, let me move the camera, and then we'll look at the overdrive section. All right, input shafts. There were two different designs in production over the years. The last design was the more robust of the two, and if you're going to do anything performance, that's kind of, you know, what you want to use. I would recommend a billet steel shaft if you're doing anything more than about 350, 400 horse, just so that, you know, you don't have any issues. I mean, I've read from knowledgeable builders about these transmissions that the second design shaft is actually good for about maybe 450 horsepower, but beyond that, you'll want to upgrade to a billet steel version. All right, so you have one piece solid Teflon sealing ring and then 2 scarf cut Teflon sealing rings. Okay, there is a sizing tool available for this. You will replace this on overhaul. All right, and of course you have your snap ring. All right, let's look at our rotation for our overdrive roller clutch. Okay, 3 wheels counterclockwise, locks clockwise. All right, so given what you've seen here in terms of the way the input shaft is, the design of the planet, and the clutch basket and all that stuff, like, what does this remind you of? All right, for those of you that are familiar with 4L80Es, should remind you of that. The 4L80E overdrive section was based largely on the 204R's overdrive section. It's just scaled up and, you know, designed to meet the needs that GM had for that transmission, but essentially it is otherwise the same thing. Alright, so check your inner race. This bushing is obviously going to need to be replaced. Alright, you can disassemble this whole planet. You have a snap ring here, but if it's in good shape, there's no reason to. Alright, this one's making noise, so we may have to disassemble and install new needle bearings. So if you're not sure and you have something like this, it's making noise, but there's no side play, soak it in transmission fluid and see if the noise goes away. Alright, just totally immerse it, and if the noise goes away, it's probably fine, but if not, then you're going to have to go back through it and make it good or replace it. Alright, 2 frictions, 2 steels in the coast clutch drum. Up, so obviously install that with the up facing U. Okay, your sun gear. To my knowledge, it does not matter the orientation, whether the bevel is facing up or the flat side is facing up. To my knowledge, in the 4 LEDs in the the sun gear in the rear, the beveled side will face face down, and the side that looks just like this will face up. Go on either way in the case of the 204Rs. Alright, check your inner race here. You want to make sure that there's no issues. Check the cam itself, make sure it's not worn. Check your teeth, or I'm sorry, your splines. And check your splines here as well on the drum itself. I'm just going to put all this back together for now. I'll deal with it later. Before we go to summary, I decided to install the pump, the input shaft, and the converter. I forgot to spin it when the transmission was fully assembled and converter installed, so you can never really rule out the converter as also a possible cause for any failures inside the unit. The majority of heat in the transmission is generated by the converter, so a telltale sign that there's something wrong with the converter or had suffered a catastrophic failure is a whole bunch of sand or really fine metal granulated looking material on the bottom of the pan when you take it off. Another telltale sign is the noises the converter will make when you spin the converter as it's mounted to the transmission. So we're kind of basically do that, but in the opposite. We're going to spin the stator on the pump to see if we can hear any kind of noises. Okay, the only time you really want to hear any noises is the sound of the stator one-way clutch inside the converter. It'll make the same sort of screeching sound that a one-way roller clutch assembly in a transmission will make. And so if you hear that, that's fine. But as I'm spinning this, I'm encountering like a tight spot. See, it's like getting tighter. And we'll spin it in the opposite direction. And I don't feel anything different spinning it clockwise. Spinning it counterclockwise feels a little different. That could be a product of just, it's never intended to really spin that way because that's not engine rotation, or direction engine rotation rather. So the other thing is you can look to see if there's metal particulate when you stick your input shaft in there. Any metals, on the pilot here or anywhere else, that would tell you that the converter suffered a failure. My converter builder usually tells me whenever the converter comes in and there's problems with it, he will usually tell me what those problems are, what he found, and so forth. So we're going to use this converter. He's going to go through it completely and build it back into like a 2500 stall, and that's what we're going to run. So just FYI, there's a crew of guys working on a roof and adjacent property, so that's what you're hearing in the background. Okay, we have a total abject disaster on our hands. There's really no two ways about it. No way to sugarcoat it or soften the blow. It is what it is. I made things even worse by getting the stupid selector shaft retaining pin, breaking it off into the case. Luckily, we're not going to use this case, but if we were, I would have to drill that out, and that'd be a pain in the ass. It's just, sloppiness on my part, but These nails are very, prone to that, so you just want to be real careful, even more so in the 480Es. Alright, so let's take a stock of what we have, which ain't much. Alright, we have a smoked, and absolutely smoked and charbroiled direct clutch and forward clutch. We saw the sealing ring groove wear there in the inner diameter on the direct clutch, and that is the proximate cause. Alright, our pump has completely damn near ate itself. The top ring has broken. Surprisingly, the rotor and slide did not. Typically when you see a ring failure like that, at least the rotor and or the slide also fail, usually both of them, but this managed to avoid that fate. The overdrive plan, it's a little sketchy. It's got all kind of noises coming from two of the pinions. We're going to soak in fluid, see if that makes a difference, but I don't think so. I'm probably going to have to go through it. The rear gear set looks for the most part okay. Low reverse clutch pack was not burnt. Center support itself looks okay. The only saving grace here is that we are not going to reuse roughly 70% of these parts anyway. I mean, the plan was never to reuse most of what we're pulling out of here, luckily. Anytime you're going north of 400 horse with these transmissions, the word billet and the word rollarized need to become a regular part of your vocabulary, and that's more or less what we're doing here. We're fully rollarizing the case, installing a billet overdrive ring gear, a billet input shaft, a rollarized center support and rear gear train. I mean, the list goes on. I'll do a build strategy video, but suffice to say that is the only silver lining when it comes to this particular unit. If this was your transmission and this is what you found, or something similar, a similar level of disaster, my recommendation would be to just simply take all of this, maybe salvage what you can, keep the valve body, keep the parts that are half decent, and then scrap the rest and go find another 204R and start working, as that as your basis for your build. You would not reuse this transmission like this. Way too many problems. I wouldn't be surprised if the case is somehow either warped or tweaked or, whatever, compromised. It wouldn't surprise me in the least. So anyway, I have quite a lot of videos on the 204R, so if there's anything that you're curious about, you want to know a little bit more, getting a little bit more into the weeds, check out my playlist. All kind of topical videos, plus a complete rebuild series. I will do a build strategy video on this because we're doing things way above and beyond anything else that's currently on the channel, so that'll be something like 204R build strategy and approaches for everything up to about maybe 500 horsepower, and you'll see that on the channel probably within the next few weeks of the publication date of this video. Alright, so this will get a complete and total overhaul. All the usual things, everything from clutches, steels, overhaul kit, filter, all new bushings everywhere, new high performance band, new servo assembly billet, possibly a whole reman pump, and then all the other hard parts that we would have to change out if you were going to, stick with this one. New one-way assemblies, wiring harness, case connector, TCC lockup solenoid, valve body kit or shift kit of some sort. Transgo's SK200 4R is a good basic kit for stock to mild performance builds. Anything beyond that, I would go with some a little bit more high speed. So anyway, as always guys, thank you so much for watching, greatly appreciate it. If there's something that I haven't yet covered on these transmissions you want to learn more about and dig into, go ahead and leave me a suggestion in the comments and I will get to it as soon as I can, make a video as soon as I can, and get it out there on the channel for you. Alright, until then, enjoy the rest of your day or evening, and as always, thank you so much for watching.